Hi, I'm Ashita Besundara. In this video, I will walk you through how I built an end-to-end Kafka-based system that processes order messages using Avro serialization, retry logics, and data queues and real-time aggregations. I will show you the architecture and the GitHub code as well as live demo how this system works. First of all, let's get the project objective. Here we use Kafka and Spring Boot based application to demonstrate how the serialization, deserializations and DLQs works, and we have one single application which runs Kafka producers, consumers and serialization, retry logics and DLQs. Let's move on to the architecture. Here is the architecture I designed for the project. The producer published order messages into order.request topic. You can see here every message follows a pro schema defined in order.avc. You can see here, defining the schemas here. .avc file. This is the pro schema, and consumer listen to the same topic that producer produced. If the processing fails, the consumer retries 3 times. If still cannot be proceed, the message is automatically routed to the dead letter queue, which is a separate Kafka topic. All at the same time, separate statistics. Consumer reads messages and maintain a real-time average of product prices, which is published to the product of stats topic. This is the high level overview architecture overview of this project. Let's move on to the code walkthrough. Here is the project application.properties file. Here you can see all the deserializers and serializers use Avro Kafka deserializer as the deserializer and serializer, and we have a separate serializer for order, or we have a separate schema, Avro schema for order and product stats, which is it gives the average prices and total orders and total revenue. Now let's move on to the live demonstration. First of all, we need to run the infrastructure, which is infrastructure services, which is Kafka and the zookeeper and the schema Avro schema registry. And here we are using Kafka UI to visualize what are the topics and other offset configurations and partitions that we are using here. Here I already running those containers like this. You can see all 4 containers are up, which are Kafka UI and the schema registry. When we move on to the Kafka UI, you can see the topics here. There is no topics, but we run this project, get created like this. It registered the Kafka and started on Tomcat server on port 8001. Let's create a API curl request, because we have created a controller to visualize how this mechanism is working, we have created a simple controller to create a order. Before we go into that, there are two topics are created, which is order created and order requested DLQs. There's no any messages here. Let me send a call request like this. It gives the order number, status, and the stuff, and here are the logics. When we move on to the order requested topic, we can see that message come like this. This is the key order, this is the price, and this is the product ID. Then let's create another order and see if that's working. 4000. Okay, so to go to topic and order requested, we have two orders, separate orders, which is 1500 and other thing is 4500, and we have a real-time aggregation, which gives the statistics of the average prices like this. This is the average price, this is the total number of orders, and this is the total number of cost, which has a real-time aggregation and gives the average price per order. In here we are configuring the retry configurations as well. We are giving maximum 3 retries and back of time period and timeout periods as well, and here we can see the order service. We have a separate topic for consume the DLQs, and here we have a separate method to send that message to DLQs. We are using retry blocks to send this message if there is any exceptions occurs in the current process. We send that order to dead letter queue and process that order.